I have a great pleasure to introduce to you KRISTIE Ebi, and she will give the next keynote lecture on protecting and promoting health in the Anthropocene. So please, KRISTIE.
Thank you. I want to thank the organizers very much for the invitation. I also want to congratulate you on a very interesting meeting. And I want to congratulate all of you that the work that you've been doing, your colleagues have been doing, your mentors have been doing, has been critical for protecting and promoting our health. And it's made significant contributions over the last several decades. And people should be proud of the accomplishments of the members of this organization. I'm going to start with a slightly unfair characterization to make a couple of points to move on to talk about the Anthropocene. So when we think about environmental epidemiology, I often think of this kind of a figure. We look into the rearview mirror, we collect evidence, we understand that evidence, we organize it in a variety of different ways, and we apply it into what looks like a pretty similar future to what the past looked like. So we've got common approaches we take. We've got a real strong understanding of how we frame the problem when we look at an environmental issue. We understand what we mean by evidence, and we've got lots of discussions about evidence. There's methods that have been developed over time. There's standard methods. We have universality in that many of the results we can use from one location and apply to another location. So there's nothing unique about a study in one place generally. We can often take it and apply it somewhere else. We have common understandings of a variety of terms, including bias, confounding, and causation. And for many of our studies, the gold standard is having some kind of controlled clinical trial. So we take a puzzle, we break it apart, and we look at a couple of pieces. I'm going to talk about a very complex future that doesn't abide by most of those agreements that we've reached within our field. I know those of you at the back, I sat in the back yesterday, there's no possibility you can see this. And that's okay, you don't need to see this. On the left-hand side are socioeconomic trends, on the right-hand side are trends in Earth systems. And what you can see is starting about the 1950s, massive change. It's called the Great Acceleration. It's part of the evidence of why we're in this new epoch called the Anthropocene. Will Steffen, Johan Rockstrom, and others took this and other information and started framing the issue of planetary boundaries, of how when we look at the global environmental changes, we're moving outside our planetary boundaries. And so you can see here, what is this pointing to? Sorry? Oh, it's a separate one. That's why it doesn't work. Thank you. Too many tools. Boy, this is fun. So this is genetic biodiversity. Here's climate change, land system change, nitrogen, phosphorus. We're well outside our planetary boundaries. So there's lots of concern about where we are as a species, what we're doing to our planet, and what it means for our own future. These are examples just for a few of these, and I put these in to make a couple of points. Number one is you can see the patterns are not the same. That what's happening in one place is not the same as what's happening everywhere else. There's places where the rate of change is much faster. There's places that are seeing multiple changes going on right now, places that are not seeing many change. And so there's a local complexity to what we would call an exposure. And that's critically important for thinking about the Anthropocene and how we're going to manage the health challenges. Specifically on climate change, this is the scariest slide I have on climate change, was work led by Detlef van Buren, who lives in Utrecht. And there are four basic pathways into the future of greenhouse gas emissions. These are illustrative pathways of where we could go with our greenhouse gas emissions. This pathway leads to about 450 ppm CO2 equivalent in the atmosphere in 2100. That's above the Paris Agreement. This one up here is pretty high emissions. It's about what we've been following for the last few decades. These are based on models of the world's economy, how many people are in the world, where they live, what technologies they're going to use, a whole series of factors, including research and development. So these are really well-developed models. They project to 2100. And you can see then after 2100, miracles occur in these particular pathways, and emissions drop dramatically. It was a thought experiment. On the right-hand side, this shows you to 2100, the radiative force, how much pressure those greenhouse gases are going to put on changing our climate. And this shows you what happens after that. We're not going to see a change in our weather patterns for hundreds of years. We've committed the planet to sea level rise for thousands of years. We knew there was inertia in the climate system here as we started emitting greenhouse gases at the end of the Industrial Revolution. We are not ever going to see the kind of temperatures that we're seeing now. We're moving beyond them. We're moving into a future that is unknown. This was published on Sunday, just to re-emphasize the future is unknown. This is Titanic 2025. Should we be on the lookout for icebergs? What icebergs? Unfortunately, that's in the realm of possibility. So I'm going to talk about futurist environmental epidemiology, of looking into a highly uncertain future that has many characteristics very different from the kinds of approaches we've taken historically. There's interactions across time, across space, and we need to think about how we work with these changes because it does cross sectors. We have to take transdisciplinary approaches. We cannot do this on our own, and if we do, we're not going to provide useful insights. Complex and cascading risks. Heat waves in Moscow in 2010, over 50,000 excess deaths, food riots in Egypt because the wheat crop failed. And a big proportion of the diet for the poor in Cairo is bread. It's subsidized by the government. The price of wheat went up. So we see these risks compounding over time and over space. Thresholds. As a good colleague likes to say, we surf the seas of uncertainties. Our exposure-response relationships are going to just change fundamentally over time. We're not going to be able to count on the exposure-response relationships we calculate today. We very much look at the distribution of risks and what that means for inequity, for environmental justice. And as I mentioned previously, the local context is critical. Understanding the situation in a particular location is going to interact with the exposures and determine the level of risk and how that will change over time. And our overall goal is to generate insights that then can be useful, usable, and used. That we very much want to inform policies to ensure that we do protect and promote our health as we go into an uncertain future. On the interaction, the World Economic Forum every year does a survey of all the members of the World Economic Forum to rate the highest risks that they see for the world economy. A changing climate is here, and you don't need to read this to see all the places it interacts with. That the business leaders, the political leaders understand how fundamental climate change, other global environmental changes are to all kinds of issues that are important for us individually, for our livelihoods, and for our ecosystems. And in thinking about then, how do we structure our studies? What is it important? What do we consider an exposure? This is a real interesting piece of work from Jan Simens at the Environmental Center for Disease Prevention and Control, looking at actual observed infectious disease threats in Europe. These occurred. And Jan had the insight to take a cluster dendrogram approach. And looking at all of these threats, the number one threat was travel and tourism. Global trade, food and water quality, surveillance comes in here, climate, environment, but you start getting down here into the kinds of issues that often are looked at when we think about emerging infectious disease threats. We're often looking in the wrong place. surfing the seas of uncertainty, we have fundamentally deep uncertainties that we're going to have to think about how we study and how we propose options for how we manage. This is work done by Sonia Seneviratne for the Intergovernmental Panel on Climate Change Special Report on Warming of 1.5 degrees. And in this study, it's a whole series of climate models, the world's warmed to 1.5 degrees. So we're just going to take that the world has warmed to 1.5 degrees. This is looking at the one hottest day per year. And this is the lower quartile of the climate models, and this is the upper quartile. You can see here in the lower quartile, if we're lucky, that much of the temperate region doesn't see a lot of change. Well, certainly we'll see quite a bit of change around the tropics, Africa, and parts of South America will see a lot of change. However, if we're in the upper quartile, we're already in a 3-degree world. And this could happen between 2030 and 2052 under current emissions. So when you think about the rate of change that could take us there, you think about the heat waves that occurred in Europe and around the world, the extremes that we're seeing. There was a heat wave last year in Japan that was declared it could not have happened without climate change. It was so extreme. We're seeing huge increases in extreme events with this rapid shift in temperature. And if we're in this world, we are completely unprepared. And we have the responsibility to find ways to increase the basket of options we have to be able to manage that world. And both of these, by the way, are equally likely. There's a standard framing that we use in the Intergovernmental Panel on Climate Change to take a look at thresholds, to take a look at how things could change over time. And I just outlined here heat-related morbidity and mortality. Where there's white, we can't tell that, in fact, climate change has made a difference. When it goes to the yellow, climate change is making a difference in this case, heat-related mortality. And as the colors get darker, then obviously the risks get much higher. Warm water corals at 1.5 degrees, Earth is warmed 1 degree at 1.5 degrees, 75 to 90% of all warm water corals will be gone. At 2 degrees, they're all gone. I do a lot of work in the Pacific. You start thinking about food security and about the reef fish that I had for dinner last week when I was in Fiji. Those are going to be gone. So you look at all of these risks and think about how they relate to health and how quickly those are coming. This is where we are today. And how we're going to start managing this rapid change in ways different than we've done before in how we frame our epidemiological studies. This was published just a couple of days ago. It shows changes in global average temperature. And this is typical of what you see coming out of the climate model. You see these nice linear changes over time. In fact, that's not what's occurring. So this is an idealized situation, and it's underestimating risk. This shows you changes from 1 to 5 degrees C above pre-industrial, where again we're at 1 degree. Heat wave frequency, major heat wave frequency, duration, hot, humid days. Again, very rapid change is coming at us. I'm not going to go through this, it was in the same paper. They looked at a whole range of different indicators, and it's mostly just to see this pattern of 1, 2, and 4 degrees, and how everything is changing at the same time. We don't have the luxury of thinking about a world where we can control everything and look at one factor changing. They're all changing right now. And we're not doing very well with our models in terms of accuracy. So this is dengue fever. This starts basically in the 1950s. By decade, there's 4 major types of dengue fever, and this just shows you the cumulative number of dengue fever types. So you can see the amount of change over the last few decades. Oops, let me go back. The mosquito that carries dengue is called Aedes aegypti, at least in the United States. Here it's Aedes albopictus. There's lots of information known about where we see Aedes aegypti and Aedes albopictus. In the United States, the buff area is about where you see Aedes aegypti today based on environmental information. It's not based on surveillance. We're not doing very well with the surveillance. And then projecting towards the end of the century, the red area is where you could see the mosquito. I live here in Seattle, it's red up there. You can see parts of the Great Lakes here. But it's not just the mosquito being present. The summers also have to be warm enough and hot enough to be able to transmit dengue. And you see a much reduced range. Again, so these are projections for the end of the century. And in 2017, breeding colonies of this mosquito were found in Toronto, Toledo, and Detroit. We're under-projecting how soon these risks are going to be coming at us. So it's magnitude and its rate. And again, everything is changing. This is some nice work again done for the 1.5 report, looking at the number of people who are both exposed and vulnerable at a 1.5, 2, and 3 degree world under an assumption that we continue to kind of muddle through the way we are in terms of our socioeconomic development. And you can see very big shifts in the patterns. Our emissions matter, as do our development patterns matter. How we develop is going to determine the extent of the risks that we are going to experience personally and that our families and our colleagues will experience in the coming decades. Local context matters. Kiribati, Tuvalu, and this is Vanuatu after Tropical Cyclone Ham. The vulnerability in different places is very high. It's not just that we're changing a variety of exposure factors, our vulnerability fundamentally interacts with that. And we have to understand the vulnerability. And the changes I'm talking about, again, everything's changing at once. I'm working in these countries right now. They're worried about extreme events. They're worried about storm surge. They're worried about king tides. They're worried about vector-borne diseases. They've got a massive obesity epidemic going on, very high rates of diabetes. They've got food insecurity. They've got water insecurity. They need solutions for all of these all at the same time. One tool that we have for looking at development and thinking about our future is something called the shared socioeconomic pathways. Our toolkit has these shared pathways. It also has policies for climate adaptation and mitigation. And then I showed you a little bit about the greenhouse gas, and that should say emissions. I'm not sure where the E went to, disappeared into the block. But we do have this toolkit that we can use to take a look into the future. We developed the socioeconomic pathways along 2 axes, one worlds with increasing challenges to adaptation, the other worlds with increasing challenges to mitigation. Those are our 2 policy levers. There's 5 of them that can be used to think about what our future will look like in terms of socioeconomics. There's storylines for each of these, and there's quantitative drivers. There's population, urbanization, GDP, and a measure of basically inequality. And you can see very big differences across these. These will have implications for the underlying burden of disease. If we're in a world with massive population growth, unplanned urbanization, high greenhouse gas emissions, and very high inequity, we're going to see very likely a resurgence of vector-borne diseases. We just are not going to have the capacity to control it. And we're not going to be investing in the research and technology development to do so. So each of these have profound implications for how we think about the future. These are being incorporated quite rapidly into lots of other studies. These only came out a couple of years ago. There's almost 500 publications. And other sectors are really taking these up to understand how our development choices are going to affect our underlying vulnerability and thereby our overall risk. I want to mention a couple other issues. One is an issue that's coming up very strongly, and I think will be the most important health risk of a changing climate. We've known for quite some time that climate change is affecting crop yields, that this is 2030, 2080, different assumptions about emissions. But basically, when you look into the tropics, most of the major cereal crops are currently growing at the thermal edge of their tolerance. So any increase in temperature and crop yields go down. Food insecurity was decreasing for many years. It's been increasing the last 3 years. There's 850 million people in the world who are food insecure. FAO thinks part of the reason is climate change. Reduction in crop yields translates directly into stunting of children. So this is some work that was done for the World Bank looking at how then stunting rates could change. And you could see bigger increases in the future. These models are complicated. They have trade in them because agricultural trade is critically important for deciding how much food insecurity is in a region. But it's not just climate change. There's recent research coming out on carbon dioxide itself. 85% of all the plants in the world are called C3 plants, and it has to do with how they pull the carbon dioxide in from the atmosphere into the plant. As there's higher carbon dioxide, the plants pull more CO2 into their structure. They grow faster, that's why you see headlines of CO2 as plant food. And the plants do indeed grow faster. There's also a competition within the plant between carbon and nitrogen. And so what you see is in controlled experiments, as you have higher CO2, the plants have about 10% less protein, and they have much lower B vitamins. This is a study that came out last year for rice in Japan and in China, and you can see folate decreases on average by 30%. You start looking around the world, and when we did the study, we looked only at the most rice-dependent, poorest countries, and estimated at CO2 concentrations later in the century, we're talking about 600 million people could be affected. And this is only CO2, it's not climate change, and it's not just the protein, it's not just the B vitamins, but these plants also become more water efficient, so they bring in less water from the soil. That also means they bring in less micronutrients. I've outlined iron and zinc, but it's all the micronutrients, about a 5 to 10% reduction. So studies using just these reductions, primarily in zinc, because zinc's so fundamentally interconnected with stunting, several 100 million children could be affected by stunting because of this shift in the plants. So this is a very big issue that we as a field need to start working on because it is going to affect so many people, and it's going to affect all of us. It's going to affect rice, wheat, potatoes. Most of the starches that you like to eat will have more starch and have less nutritional quality to them. There's lots of other changes going on. Right now, there's been a big shift. This is just the United States. In the United States, transportation is now our major source of greenhouse gas emissions. It's no longer coal-fired power plants. Only China could put in massive installations of solar cells that look like that. It's pretty amazing, isn't it? China also will quite soon be testing a 100-person electric plane. So the technology change that's going on right now is fast. It's really amazing. And we need to be at the table to make sure that those technologies are associated with jobs that don't have adverse exposures. We want to make sure that we protect and promote occupational health. You've heard quite a bit at this conference about co-benefits. There was a nice session yesterday, so I just thought I'd put in two. This is from Alistair Woodward. I don't know where he got that picture, but it's a fantastic picture. A study that he did in New Zealand of just shifting 5% of short urban car trips to bicycles. And they did a full assessment. Would save $200 million in health costs with about 116 deaths because of 116 deaths due to increased physical activity, but 5 road deaths. So you'll see a positive I said that poorly. So the number of deaths will go down because you're going to have more people who are physically active, but you have to acknowledge that people will be killed in car crashes as well. And there's lots of other studies. We just heard about a few of them a few minutes ago, but this is reductions in premature deaths due to PM2.5 and ozone from accelerated reduction of emissions of CO2. And so these are annual deaths. The dark colors are 100,000. You can see really big benefits. Most of the studies that estimate the health co-benefits of emission reductions, and these are the co-benefits of reduced hospitalizations, reduced premature mortality, whatever economic metric you want to use for value in that, the total value of those health benefits is generally of the same size or larger than the cost of mitigation. So when you read in the media that achieving the Paris Agreement is going to cost 1.5% of GDP, you need to think about the real benefits there'll be for health. These are immediate benefits. We can start saving lives now by making changes in our diets, in our transportation systems, and will help save our planet in a way that's more familiar to us than perhaps it would be otherwise in the longer term. All of this, of course, was in the context of achieving the Sustainable Development Goals, a series of aspirational goals that are not entirely internally consistent. One of the really impressive activities undertaken for the special report on warming of 1.5 degrees is the authors in Chapter 5 went through and looked at energy supply, energy demand, and land, and looked at the synergies and trade-offs. And this is a really exceptionally large amount of work and exceptionally useful work. So some of the studies in there pointed out, for example, I said that if we keep emissions fairly low, when you look at the models of how we can keep those emissions fairly low, they all have a lot of biofuels in them. As you increase biofuels, you take land away from agriculture, you increase food prices, and you increase food insecurity for the poor. There's synergies and trade-offs for all of these, and we need to understand these synergies and trade-offs to help inform options. It's not that we shouldn't keep emissions low, but we have to think about how we're going to manage the change in food security for the poor. We have a pretty broad research agenda. I'm standing between you and the coffee break, so I'll happy to talk about this later, but we've got a very large research agenda. We very much would invite everybody to come participate in this research agenda. And with that, thank you very much.
Thanks very much, Kristie, for a very wide-ranging talk. It's very inspiring and I think and helpful for all of us. We're now getting into the coffee break. We're a little behind time, and if you take your coffee quickly, you can make up for that when getting to the next session by 10:30.